Hi, let us see how an automatic voltage stabilizer works in solid state manner. We call it solid state because we do not use any electromagnetic relay, but we use triacs for switching on the different tappings of the transformer. This is the full circuit. We will explain one by one. The standard connections are not shown, like for example we have a microcontroller and then microcontroller some standard connections, but only we are interested in what we are using is the port 0 as the output and port 1 as the input. So these are the and then also to certain extent port the interrupt pin to certain extent of port 3.4, right? And we have used one A to D converter. That A to D converter is ADC 0804, and with the standard connections of ADC 0804 we interface it to the microcontroller. And the input voltage in fact is the if we look at the ADC 0804, this has the standard connections like clock and then the reference voltage. Reference voltage we are given from the 5 volt supply at 10k, so we get 2.5 volt at the reference voltage here. And for the V in and negative and positive, negative is grounded, but positive we are giving certain voltage. Here for the purpose of simulation, what we are doing, we are giving through a potential divider arrangement, so that what we will see that while we change this voltage, how the different triacs are being fired. And we know that if we have our 6 triacs to be fired, and those 6 triacs will fire depending on the voltage condition here. So what I have done is we have also connected 1 voltmeter across the input terminal. This is the voltmeter. We can see the voltage as to what are the voltage changes which takes place. This voltage in fact will be coming from the input side, duly filtered, and preferably a RMS filter. And then what we do is we provide the DC here, and then that DC would be controlled by this and calibrated by this particular potentiometer, right? And then as far as the solid state portion is concerned, what we are used is so these are the output pin number 39, 38, 37, 36, 35, 34, 6 pins we have used, and we have numbered the opto isolators input accordingly. Now we have taken few opto isolators. This is 39 here, we can look at this, okay, 39, 38, like that. And opto isolator, what we have done, since we are using port 0, it is not necessary that we must pull up the port 0, but this is how it is pulled up. Now this goes to positive, this goes to a 100 ohm resistor, and through the LED of the opto isolators goes to pin number 39. You may or may not pull up the port 0, though it is mandatory to pull up port 0. But here, since we are already doing in this arrangement, port 0 pulling up is not necessary. Then on the so that's how all the pins are connected from 39 to 34 to the opto isolators, what we have taken here. And we have taken here actually a ZVS opto isolator. What is the ZVS opto isolator? It could be MOC3031, MOC3061, MOC3063. These are the kind of zero voltage opto isolator. The advantage is that the switching takes place only at the zero crossing of the supply. That's the biggest advantage of using the zero crossing type opto isolators. Then the connection from the output of the opto isolator, we have a supply, and in the supply the ground point, of course we had made a ground, it not necessary that must ground it. And then we have a lamp in series and the track, and this is how the path is, and this will form the tapping of the transformer, right? Because all other points are common points. What we can notice here, that these are all same alternator, all the same supply, and these points, all the common, these are all the common points, and these will be the tapping of the transformer. 6, 1, 2, 3, 4, 5, 6. 6 tappings of the transformer which will be switched on based on the input voltage conditions. Now that is how it will work. Now let's see how we simulate this and how it works. As far as the track firing is concerned, as that has been separately explained together with the opto-isolator. While this this goes to positive, power flows this way, this way, this way. It cannot go this way. It goes this way, this way, this way, and it passes through 0 or a reference only if the light from the opto-isolator is falling on this, and then only the track conducts and this path is complete. And that is how this is the path which completes. And like that, all of them are working. And now when we simulate this, what we find 1.3 volt, 1.3 volts. This voltage is the input voltage is around 1.3 volts. At 1.3 volts it is tapping 1. Then when we switch over to, when we go to at tapping 2, now this says to tapping 2, and the tapping 2 the voltage is 1.6 volts. Okay, you can see it better. Tapping 2, it is 1.6 volts. Now again come down, sorry, we are going up. Okay, now this is tapping 3. Tapping 3 is 2.1 volts. If you could see, tapping 3 is at 2.1 volts, right? And then tapping 4. Tapping 4 is at 2.55 volts. This is around 2.55 volts. That is tapping 4. This is tapping 4. You can see this. It's tapping 4. Right? And we go further. Now it goes to tapping 5. What is the voltage at tapping 5? 3.2 volts. Right? You can see it is 3.2 volts. Right. Then go to tapping 6. This is tapping 6. This lamp has come. This lamp has come, or tapping 6 has come. Okay. Now what is the voltage at that time? Yeah, 3.65. That means from 1 point certain voltage to 3.65 volt, which will be changing based on the input voltage change, which will be filtered, rectified, filtered, made DC, and then this voltage will be applied here to the ADC, and then the ADC gives the digital 8-bit data, and that data is given to the microcontroller, and ultimately the output is derived from the port 0 and given to the opto-isolator, and opto-isolator in turn triggers the corresponding track, and which switches on the corresponding tapping of the transformer. And the tapping, you can just get a look at it. Hello, if you want to try this circuit, what you do is you take a manual autocode transformer, which is very easily available in the market, and this has got, these are the tappings which is got, and that is they use relays for now this is the supply, and whichever relay is switched on, based on which the output is it behaves like an auto transformer, and this voltage is vector addition takes place, and then you get the higher voltage here or lower voltage depending on the relay switching that takes place. So this is how in a relay manner it happens, but what we are doing, our objective is to use tracks. This is how it should go to the transformer. Another view of the same, how do we connect transformers? Actually these are the track points, instead of these are called relay wise. If you don't have the relay wise, you can always have the all the one side of